Okay, so what do we want to do first? Let's do a small incremental step, right? We don't want to do everything at once. We do an incremental step and work from there. And the idea, as I showed you guys, is to add those circles as SVG. That was my idea. Because with SVG we can have a little bit of flexibility on how to draw and how to interact with these nodes. It's like building a small graphical library in a way. So first step, let's see how we can draw a circle. I'm not Giotto, but I will grab the code that I prepared, which is pretty simple. And it's this one. Okay. Another thing I might need is the prettier. Of course. Grab. So now when I save it, yay. Look at this sexy code. So what do we have here? We have an SVG box with the it's a square, 600 per 600 width, 600 height, with a background of white, and then basically two circles inside, like that. This is what we have. One circle is bigger than the other, and it's filled with blue. It's basically that, and an inner circle which is just filled with red, and the radius of the inner one is smaller, so 18, right? For example, we can edit, let's say, side by side. We could say radius 15, then it will become smaller, the red one, right? You see? And then the blue one, then we have some text with X and Y coordinates, and everything is relative to this square box. So the white square box is the SVG. It's not responsive at the moment, but this is a good starting point. What we want to do is to add multiple circles like this in the canvas, and they should be organized as a ring, like as a circular way. Let's add another one. Let's add another circle. Let's grab this, copy and paste. The most famous strategy for usability. And here we have the X and Y, which will be the position of the circle itself, so the center. This one will be 100, 100. So roughly this one will be 1/6 of the width and the height. So maybe let's put it at about 200, and this one as well, 200. Boom, we get this one here. So yes, the concept is working. So you guys see how I proceeded. Incremental step. You do a little iteration, which doesn't take too much time, and then if it's working, you can proceed. The next step would be testing whether the interaction works or not. So these are SVG. Usually in React, we have to do with HTML elements rather than these SVG, like buttons, forms, divs. So would that work if we go, for example, hover an SVG? Are we able to hook the React world with the SVG? Well, let's figure it out. How do we do it? I knew the answer before, but the answer is yes, because you can hook the on mouse enter, for example, with one of the elements of the SVG. So what happens? Take a look here at the console. I've added a little bit of a console log, enter circle when we go in. So let's see if it's true. Drum roll, boom, yes. So both of them, you see, 1 and 2. It's working. Awesome. At this point, we are in a very good position to proceed with the next step. So next step obviously is that we want to draw all these points, all the nodes in a circle. They have to be organized in a ring, let's call it. But the number of nodes is a variable, so we don't know whether they are 2, 5, 10, 20, because this would be ideally it could be the number of Wi-Fi networks around me, which could vary in time. And so how about we make this example dynamic to support the number of nodes, like with a for loop. We had the number of circles dynamically. Okay, so loops is the most powerful weapon in the belts of developers for sure. Let's say we have a const here with number of nodes, and that would be, say, 8 in an octagon. And then here we want to add a for loop. Actually, I was thinking maybe it's best. Let's have. Oh, look, he knows what I'm thinking. What the heck? Yeah, nodes. We want the nodes. And we want this to be an array of nodes, of course. Boom, not bad. So this is the auto completion of Copilot. ID X Y R. Yeah, let's go with that. To be honest, we don't need any of these at the moment. It doesn't make much sense. But let's have a little bit of a structure of nodes so that we can loop over it. And here we create a loop, so nodes, and then we do the map. He knows, kind of, and we have node the index, and then of course what we want to do is to return. Look at that, we want to return the SVG element node R. This we don't, I don't know why it's minusing that. Let's test it. He also knows that I want to do the on mouse enter, which is kind of sweet. So let's see what we get. Okay, 2 nodes. Maybe let's add another one, which is exactly what we had before. Let's add a third one, maybe 300. Look at that. It looks like that game. Forza 4 was called in Italian, or tic-tac-toe. Anyway, it's dynamic. So second step, I would say, it's done. We're capable of grabbing from an array of nodes and then display this in SVG. All right, but now we want to organize them in a circular way. And here we need a little bit of trigonometry from high school that I prepared. I'm excited to have a look at that. So let's switch to a little bit of formulas. Very simple. Okay, so we have a circle and we want to add those nodes in a way that they are equally distant one to the other. So the key would be to calculate this angle. And if we have 4 of the nodes, then we need to have an angle which is divided like this, like a pi. Talking about pi, we have to remember the concept of pi. Like this would be the 0 angle, and then here we have pi, of course, and this would be 2 pi. So this is half pi, right? and this is 3 times the half of a pi, 1, 2, 3. Okay, so this was pretty basic trigonometry. So how we define the circle here? Circle, we had x equals to the radius multiplied by the cosine, the angle. Then we have y would be the sine instead. Okay, so the angle that we want is I, which is the index of the nodes starting from 0, divided by the total number of nodes, and then we want to multiply by 2 pi. So what we want to do essentially is associate the number of the total nodes with the angle, because this will be the one of the variables. We don't know upfront how many nodes we have. If we have 4, like here, we know that the first angle will be 0, the second angle will be 90 degrees, so this one, pi divided by 2, the third one will be pi, and the fourth one will be 3 times pi divided by 2, right? So this is the case when we have 4. If we have more, like for example, the simple case, let's do the basic. Or the basic is you have 2 circles, right? One here, one there. In this case, is one is at the 0, and the other one is at the pi. Let's see if it's true. So we have the first one would be, first index would be 0, so 0 multiplied by whatever, the first angle will be 0. So in this case, this is the first one, with I equals 0. And here, I divided by the total number of nodes, which should be 2. 2 and 2, they simplify themselves. So in the end, we have pi. So boom, this formula works. This would be I equals 1. And so on and so forth. So if we have 8, let's see. Oh my god, my circle is horrible, but we have 8 circles here. And so, for example, this one is 0. It should be the easy case in which I is 0. But then the second one would be this one, which is, remember, this is pi divided by 2. So this is one is pi divided by 4, right? So 1, 2, 3, 4. And this is right because the index is the number 1. So in IT, we start counting from 0, and this is number 1, divided by the total number of nodes, which should be 8, multiplied by 2 pi. So we simplify, and then we have 4. So this one is equals to pi 4. So awesome. So what do we have now? We have a way of dividing the total nodes into the angles. We can convert the number of the nodes to a list of angle. Like here we would have the 0, then the second one we would be, of course, this that we calculated, and then that one, and then we would have 1, 2, 3, 3 times, can simplify like this, and then we would have 4, and so on up until we reach the end, which would be 8 times pi 4. Okay, so with this list of angles, we know that we divided the big ring into
slices of the same size, essentially, or the same angles. And then with a simple formula, we can place this circle on the Cartesian coordinates, right? So the formula that we need would be that x equals the center x, which could be 0, but here comes the interesting part. It's the radius multiplied by the cosine of the angle. And here, y is the center y plus r, the sine of the angle. So what are we saying? We take this angle one by one, we push it into this formula, and essentially we get the position x and y where we can center all these circles. So it looks complicated or simple depending on your math skill, or trigonometry, I'd rather say. But let's see in the code. It's going to be just a couple of final codes, so don't worry about it. I made a mistake, obviously, before. This is 3 times pi divided by 4, and this is 4 times pi divided by 4. Obviously, because this is 1, 2, 3, but this is 1/4 of the pi. Anyway, so this is fixed. Now, I also wanted to add a little bit of a reminder of how we can, how the sine and cosine are associated with the coordinates. So by definition, we have a circle of radius 1, and when we have an angle, whatever it is, then the projection on the x-axis and the y-axis are what you're interested in. So we can convert obviously the angle to this coordinate x, y, and then we can position on the circle. So what we have is that x equals, this would be obvious for most of you, but repetita iuvant, said the Latins, the things repeated help. And then we have the y, it's sin of theta. So we have the angle and we can get the xy. This is what we want.
Okay, welcome back to the code. So let's try to implement those formulas into the code, right? What we want to do, these are the magic lines. The first thing that we want to do here is basically for each iteration, this is the magic line, for each iteration, for each index, we are going to calculate the angle. Let's see what it is. We trust no one when we work with computer. Let's see what these angles are when we are dealing with 1, 2, 3. Let's set it another one, maybe 1, 2, 3, 4, which was one of the simple cases I showed you before. Let's refresh it. One is overlapping to the other, of course. Maybe let's put it in 400. Boom. Okay, you guys see, these are the angles. One is 0, and then 1.5, 3.1, 4.7. Now we are not using them. We need to reposition them later, but we are doing the loop and calculated the angle that need to be used for the coordinates. So this is a good starting point. Second step is to add the coordinates, and we want to use those angles for calculating the position of x and y. For this time, let's say the center being 600 per 600 would be, 300 in the middle. Let's hard code them. We are going to refine it later, and the radius may be a little bit less, so something like 250. right? So this 250 is the radius of the ring. We're not dealing with the little circle, is the radius of the ring, which is a little bit less than half of the height and width, right? So half would be 300, we do a little bit less. Okay, and let's print them, right? See, G, X, Y, okay. So you guys see these are popping out. X, 500, 300, 300, 550, cool. And now we can use them to reposition. Let's keep this here for the magical theatrical effect of seeing them being positioned in the right place. I don't know if that makes me a nerd, probably does. Anyway, let's place this Control D. Do you guys know Control D? It's to select similar thing, similar pieces of text. And then let's put in the Y. Let's see. Yay! Awesome. It's a good feeling always to see things working. So here we have 4. Look at that. They are perfectly positioned. What if we add another one? Or a couple more, let's say. So this X and Y, they don't mean anything anymore. You remember what I did? What I did is recalculate basically this X and Y so we can get rid of the position. Bye-bye. See you never. And goodbye. Okay, it's still working. Let's add, what did we say? A couple more. Same ID, really bad programming, but we just want to have something in the array. Let's save it, and wow, look at that. It's a hexagon. Makes me think about my Dungeons and Dragons days. So yeah, we assume that it's a good starting point to achieve what we want, to have a dynamic way of drawing this circle well spaced in a ring. Cool. Next step, I would say, how about refactoring a little bit? This is terrible. We have all things in app, obviously. It's good for having a minimal MVP, so to speak, the minimal the function running. But now let's bring maybe a little bit of this code inside a separate component, right? Let's call it maybe a ring node or something. We would have one component for the ring and one other for the little inner part. So let's start refactoring and separate this part. Okay, cool. So new file, components, let's call it ring node tsx rough CE. You know, guys, this stuff. There's an extension for VS Code to have some React snippets of code. So this would be RAFCE, which is the functional component. Cool. We have it here, the ring node, and we can, of course, this is React. That's all what it is. Components and functions, and the rest is up to you. Okay, so we can use it. Ring node. There you go. It's not there. Yes, it's not there. Fair point, because we are in a SVG. So I wonder what the hell did they put those. This stuff needs to be the inner part of the SVG. We wouldn't see this div. To be really interested to see where did they go, but we kind of don't care. Let's just bring what we need inside the ring node. So let's take these, and then let's say it was called React fragments or something back in the days. Everything's gonna explode, of course, because X and Y are not defined. So we need to have those parameters, those properties defined here. So what is gonna be, probably you want to pass the node, and then let's call it X and Y. Yeah, it could work. So X and Y, node R. So here we pass the node, which is gonna be the node, and then X, whoa, Z, not in the third dimension. The X, you need to pay a little bit of attention, is what we calculated, right? I wonder if it's the right place here to calculate this stuff. I'd say so. I say it's good to calculate it outside and pass it for now. Okay, it's working, but why do we have these errors? Because we're using TypeScript, so we need to add a little bit of types. There we go. Of course it's here, and I forgot this. And then these properties could be defined. We could slap in any, right? Any, and that would work. I will discuss this a little bit more. First, let's see if it's working. Let's remove this. Do we get a pentagon? What the heck is that? Oh, pentagon. It's right. So perfect. It's working. The property are passed. So what I was talking about here, that back in the days we used to define all these properties with the React props was called, which was horrible. Don't want to see the thing anymore. What we can do is just use the interfaces, right? We are in the TypeScript world, and we can say that the properties are gonna be, now I just do a little bit of temporary thing. Yeah, and yeah, good AI. You see, right? Is AI gonna replace us? It's good to have an AI auto completion and stuff, but we are guiding. We are still in charge. Okay, so we have an interface which is defining the types that have been passed. So when we pass, of course, something which is not a number, he's gonna flag it to us, like we say Chicho. So he says, hey, this is not a number, you know this stuff, right? But it's good to see that again. So we did a little bit of refactor. Now we have a ring node. So you see, proceeding incrementally, you do a little bit of experiments, and then you clean the code later until it's the cleanest code in the world. Okay, so what's next step? Next step, you're reading in my mind, is let's refactor the node ring itself. We don't want to have this stuff in the app, of course. So let's create another component. My God, let's fix it. Component. Yeah. Let's move. I'd say let's create another folder, and let's put each component in its own folder. Ring node. Yes, please. It's already there. You know this, I didn't commit anything, which is not the best practice. I'll do it in a sec. New file, ring. The ring of fire, the ring of fire. So we got the component, we got the ring of fire. And now, again, we have to think a little bit of what this would be. It's not a normal component. We will have like the container part of the SVG. This would be like the frame of the SVG itself. And this could be probably properties, or maybe we can hard code it for now. But so first thing, let's see it in action here. Ring, boom. Yes, we have it, and we love it. And now we are going to move all this nice code in there. Something disappeared for the moment. And then we are here. He doesn't have the nodes. Let's move them. Let's clean. Destroy, erase, improve. Yep. Let's move them here. Should be back in business. No. Okay, let me check. He's complaining about read node because I messed up with the file positions. Yeah, he's back. Okay, now we tidied up. We did our homework. Let's clean this thing as well. So I say it's not too bad. The components are a little bit more decent. Now, maybe let's think about if we want some properties to be added, to be passed, and rather say to this component itself. Maybe for now let's leave it as it is. We just want to have it separated. We will end up also adding some styling for sure, instead of hard coding things like background color. So let's do that. Let's add a new file called ring.css, and then here we want something like import it. Let's close everything. Let's import ring. Haha, he doesn't know that we have a CSS. Look at that AI, I gotcha. SCSS. And we want to add this background to port it here. So ring container. How about aqua? But we need to remove it from here. And boom shakalaka, we have it. Okay, nothing interesting, but you guys don't want to add a CSS rule inside the code as much as possible, inside the component code as much as possible. So this is a little bit of an improvement. We will also add a ring node.scss and wire it at the top. Import, see if it learned. Did you learn from your mistake? Dot. No, he doesn't know. He doesn't have the context. That's why probably if you use something like new fancy IDE to detect that he needs a CSS. Anyway, good. So next step. Okay, next step, I was thinking, how about we try to use a little bit of more realistic data. So if the use case would be having Wi-Fi networks here, let's try to mimic what the real data would be like. I prepared it, and it could be something like this. So we have two kinds of data structure to be aware of. This could be a list of the networks available, SSID, signal strength, encryption, band. You're familiar with that, right? And so let's copy and paste it. Let's copy and paste it here inside the ring. And let's call it maybe Wi-Fi nodes. Okay. All right. So you guys see, we don't care. Or there is one thing that we should care about now that I look at the code, is the radius, because it's used here. So it's using the radius to essentially decide the size of each node. We don't need it. You can bring this stuff. It's magic constant here. 20 is minus 5. I guess it's 15. Yeah. Still working. Still happy. What else? Oh, here. So it made sense because this is the outer circle and this is the inner, which is smaller. So this would be 20 and this would be 15. Okay. Okay, so let's get rid of that. This is kind of one of the important moments I say when you wire dummy data with kind of more realistic one. So now we have the Wi-Fi nodes will be the things that we are circling through. Let's save it. I think the name is gone, so it's gonna complain somehow. Yeah, we have 3. 1, 2, 3. So good, the name disappeared because we don't have it. What we want to do is grab, what do you guys think? Let's grab the SSID, which is the name of the Wi-Fi. So no worries. Just put it here so we can see in real time. Instead of saying node.text, it's gonna be node.ssid. We should definitely define, boom, there it is. Should definitely define this in types. Because you see, the advantage of using TypeScript is that you say dot, we would like VS Code to extrapolate the fact that this is the shape of the data. Because if I say blah blah, all right, it's not displaying anything, but it also compiled. So this is not the best ideal way of using TypeScript, because here the node is any. So at this point, we start doing something a little bit more properly. We define the shape of the data and we start shaping our domain.